rural stretches of roadway throughout much of Ohio, there isn't enough traffic to warrant the installation or use of traffic signals at most intersections. At these intersections, it's primarily stop signs that are used for traffic control. But at some of these intersections, stop signs aren't effective in providing public safety. Are intersection control beacons the solution to the problem? In this video, we will examine the question, to beacon or not to beacon. The decision whether to install intersection control beacons can be a difficult one, because there aren't many guidelines to determine which course to take. On the one hand, intersections that aren't operating properly may be a risk to the public. A high incidence of stop sign violations and angle-type accidents suggest that stop signs are simply not being effective at controlling traffic. When such conditions exist, intersection control beacons may be recommended. According to the guidelines already established in Ohio, the presence of such problems could indicate the need for better identification of a stop condition, or that drivers may need to be advised of an intersection's existence, which would justify the installation of intersection control beacons. On the other hand, engineers are concerned about the use of intersection control beacons. Many believe that overuse of these devices will cause drivers to ignore them, which could also jeopardize public safety. Until recently, few guidelines existed to assist engineers in making uniform and objective decisions for the use of beacons. A study recently completed at the University of Cincinnati made recommendations on the situation. Here, Prahlad Pant, Associate Professor of Engineering at the University of Cincinnati and a researcher in traffic engineering and control for 13 years, headed an investigation into the effectiveness of intersection control beacons.
The purpose of this research was to investigate driver behavior and accidents at low-volume rural intersections controlled by intersection control beacons. Our goal was to develop guidelines for the installation of intersection control beacons. We felt that the guidelines that exist today at ODOT are not adequate for engineers to make an objective decision to install intersection control beacons.
Pant studied intersections with and without intersection control beacons, with the idea that if these devices had an effect on driver performance, this should lead to observable behavioral differences. In the study, two forms of information were gathered about a variety of intersection types. One of these was to investigate the accident histories of intersections with and without intersection control beacons. The other was direct field observation of driver behavior at both types of intersections. 26 intersections, consisting of 4 geometric types, were chosen for the field study, evenly divided between those with and without intersection control beacons. The principal intersection type studied was a 4-leg intersection with a 2-way stop. The other intersections were T-type, a 2-way stop at an intersection with a divided highway, and a 4-way stop. To collect accident data for intersections with and without intersection control beacons, the team poured through accident files for the various types of intersections on file at the Ohio Department of Transportation. Accidents were studied according to several categories: their characteristics, the day of the week the accident occurred, and accident type. ODOT records were also used to select the intersections for the field study. For the field study, Pant studied driver behavior at selected intersections by observing their approach speed, whether drivers stopped at the intersection, and if they did stop, the amount of time or service delay that the vehicle remained stopped at the intersection. The gaps between vehicles were also recorded. Two further considerations were also included. Intersections were classified according to the driver's ability to see the intersection during the approach, and traffic volume moving through the intersection was also considered.
Okay, what made this study different from previous studies is that we were able to look at driver behavior at a macroscopic level. That is, we were able to examine driver behavior shortly before a driver arrived at the intersection and continue to do so until the driver left the intersection. In that way, we were able to tell how each driver behaved at intersections controlled by stop signs only and at intersections controlled by stop signs and intersection control beacons. And we could see the difference between.
To conduct the study properly, a means of accurately recording driver behavior had to be found. A system of 6 camcorders was ultimately selected for the project. The camcorders were chosen for their ability to generate a time record called a time code. Accurate to a 30th of a second, this time code is recorded on the tape along with the video signal. In this way, the camcorders would provide not only a detailed record of what occurred, but also when those events occurred. The ability to provide a visual record and a precise time of events made the camcorders particularly useful at analyzing and coordinating the collected data. A camera on each approach was used to determine the speed of each car coming to the intersection by recording the time it took the vehicle to cross a marked distance. The remaining cameras were placed at the stop bar of the minor approach to record whether the vehicle stopped and the time it remained stopped. After painstaking effort to reduce the data and perform a statistical analysis, Pont had his conclusions. The study showed that there were no differences in speeds on minor approaches at intersections controlled by beacons as compared to those with stop signs. However, the study indicated that speeds on major approaches at these two types of intersections were different, speeds being lower at beacon-controlled intersections. The study also showed that beacons were not effective in reducing stop sign violations, nor did the presence of beacons appear to have an effect on the gap acceptance of most drivers. The study also revealed that the installation of intersection control beacons did little to reduce the number of accidents or types of accidents that occurred. From these conclusions, Pont was able to draw the following guidelines for future implementation of intersection control beacons. Pont recommends that the present guidelines should be modified. Pont suggests that the use of beacons be discouraged primarily to maintain driver respect. He also recommends that because they have such a minimal impact upon driver behavior at intersections with adequate sight distance, that their use should be avoided. Though a slight speed reduction was observed on major approaches when intersections were controlled by beacons, Pont recommends against their installation for the purpose of speed control. Instead, he advises other methods for controlling speed should be tried. Pont also recommends that beacons not be considered as a means to reduce stop sign violations. The report also notes that beacons were not always effective in reducing the number of accidents. The report further recommends that the suggested guidelines be added to the Ohio Manual of Traffic Control Devices. In light of this study, engineers charged with traffic safety and control can now have access to new criteria for making a decision on whether to beacon or not to beacon. Information in the previous video was obtained from the report Development of Guidelines for Installation of Intersection Control Beacons by Prahlad Pant. Copies can be obtained by writing to this address.